Hello, and welcome to Astronomy Daily. I'm Anna.
And I'm Avery. You're listening to Season 5, Episode 42 for Wednesday, the 18th of February, 2026. And what a day to be a space fan.
Absolutely. Tonight, right now, in fact, the moon is sliding so close to Mercury that it's actually hiding it from view for skywatchers in parts of the southern United States. A genuine celestial magic trick happening as you listen.
And that's just one of 6 stories we're bringing you today. We've got NASA's Artemis 2 on the verge of a crucial fueling test, a European rocket making a big move in the satellite broadband race, a genuinely new twist in the ongoing saga of our interstellar visitor, and 2 stories that I promise will make you rethink some things you thought you knew about the solar system.
Big show. Let's get into it.
So Anna, let's start with the biggest space story of the week, and honestly the one that could define the year, Artemis 2.
Yes, for anyone who needs a quick refresh, Artemis 2 is NASA's first crewed mission around the moon since Apollo 17 in 1972. 4 astronauts, Reed Wiseman, Victor Glover, Christina Koch, and Canada's Jeremy Hansen, are preparing to fly a 10-day loop around the moon and back. No lunar landing, but a crucial proving flight before we put boots on the surface.
And they are so close. The rocket is sitting on pad 39B at Kennedy Space Center right now. But before NASA will commit to a launch date, they need to successfully do what's called a wet dress rehearsal, a full practice countdown where they actually load the rocket with fuel and take it right to the edge of launch, then drain it all out again.
They did that once already, on February 3rd, and it didn't go smoothly. A liquid hydrogen leak cropped up, the exact same kind of problem that plagued Artemis 1 3 years ago. The countdown was terminated at T-minus 5 minutes and 15 seconds. Close, but not close enough.
Which pushed the February launch window off the table entirely. NASA Administrator Jared Isaacman was fairly philosophical about it. He said this is exactly why you do a rehearsal, to find these issues before you're flying with crew. But the clock is ticking.
Since then, engineers have replaced 2 seals and a clogged filter in the hydrogen fueling system. They ran a partial confidence test on February 12th to check the repairs. And now, tomorrow, February 19th, they begin tanking day for the second full wet dress rehearsal.
This is the one that counts. If the test goes cleanly, no out-of-limits hydrogen concentrations, countdown proceeds all the way to the terminal phase, NASA will analyze the data and set a launch date. The current earliest possibility is March 6.
It's worth noting just how historic this mission is beyond the moon return angle. Victor Glover will become the first person of color to travel beyond low Earth orbit. Christina Koch will be the first woman. Jeremy Hansen will be the first non-American. Every single person on that crew is making history in their own right.
So tomorrow is genuinely a day to watch. We'll be keeping a close eye on how the tanking goes, and we'll have updates as they come through.
All right, let's bring it back to Earth, or rather to the sky above Earth, because tonight is one of those rare evenings where if you happen to be in the right place and you look up at the right moment, you'll see something genuinely extraordinary.
2 things, actually. First, the moon and Mercury. Tonight, February 18th, a slender 1.5-day-old crescent moon is passing extremely close to Mercury in the western sky just after sunset. And I mean extremely close.
For observers along a narrow band of southern U.S. states, we're talking Arizona, New Mexico, Texas, Louisiana, Mississippi, and Georgia, the moon will actually pass directly in front of Mercury and block it from view entirely. That's called an occultation. Mercury literally disappears behind the moon's dark limb and reappears on the other side.
For everyone else across North America and beyond, it won't be a full occultation, but you'll still see a dramatically close pairing. East Coast observers will see Mercury sitting just north of the moon as twilight falls. By the time darkness reaches the West Coast, the moon will have shifted to within about 1 degree of the planet. Venus hangs brilliantly below them as a helpful reference point.
Now, the window is tight. Mercury sets not long after the sun, so you want to get outside as soon as the sky darkens. Look low in the west-southwest. If you can spot Venus, and you'll have no trouble doing that, it's blazingly bright. Mercury will be nearby. The moon makes it easy tonight.
And if that weren't enough, Jupiter watchers have a treat too. Tonight, Ganymede, Jupiter's largest moon and the biggest moon in the entire solar system, is transiting across Jupiter's face. East Coast observers can see it underway as soon as it gets dark. It takes just over 3 hours to cross the disk, and then Ganymede's shadow follows it across, creating that striking black dot effect on Jupiter's cloud tops.
So tonight really is a 2-for-1 skywatching event. Mercury and the moon in the west at dusk, Jupiter and Ganymede in the southeast through the night. If you have binoculars or a small telescope, even better.
Get outside.
Staying with today's news, and this one happened literally today. Europe's Ariane 6 rocket has successfully launched 32 satellites into orbit for Amazon's Project Kuiper.
For those not familiar with Kuiper, Amazon has been quietly building a large constellation of broadband internet satellites designed to take on SpaceX's Starlink. This is a big commercial play. Starlink currently leads the market with thousands of operational satellites, but Amazon has the resources and ambition to make this a genuine competition.
What's notable about today's launch is that it used the most powerful configuration of Ariane 6, flying with 4 strap-on boosters rather than 2. It was essentially a statement of capability from the European side of the commercial launch industry. This rocket can handle serious payloads.
There's also a bigger picture here. Ariane 6 has had somewhat of a turbulent road. It came in behind schedule and faced some early technical hurdles. But launches like this, winning commercial contracts for a high-profile constellation like Kuiper, are exactly what Europe needs to keep its launch industry competitive in an era dominated by SpaceX and an increasingly capable Chinese launch sector.
The broadband satellite race is one of the defining infrastructure stories of this decade, I'd argue. Starlink has already changed what connectivity looks like in remote areas and conflict zones. Kuiper, Amazon's OneWeb investments, the Chinese Gowong constellation, they all point to a future where low Earth orbit becomes genuinely critical economic territory.
Today's launch is one tile in that much larger mosaic, 32 satellites closer to that future.
Now, an update on our interstellar visitor, and I do mean update. There is genuinely new information here, happening right now.
I know we've given 3i Atlas quite a run over recent episodes, but this one earns its place today.
Completely. For new listeners, 3i Atlas is only the 3rd interstellar object ever confirmed to pass through our solar system. It arrived from outside our stellar neighborhood, swung around the sun last October, and is now heading back out into the galaxy forever. We will never see this object again.
But here's what's happening right now. ESA's JUICE spacecraft, that's the Jupiter Icy Moons Explorer, currently en route to Jupiter, passed within observational range of 3i Atlas back in November last year. Due to the challenging thermal conditions during JUICE's transit through the inner solar system, the data it collected couldn't be downlinked straight away. That data is now being transmitted to Earth. The window is February the 18th to the 20th, today.
If successful, these would be the closest ever observations of an interstellar object by a spacecraft. Now, JUICE didn't do a dedicated flyby. Its trajectory is locked in for Jupiter, but even opportunistic observations from its suite of cameras, spectrometers, and particle detectors could give us a perspective on 3i Atlas that no Earth-based telescope can provide.
And the data would complement an extraordinary recent run of discoveries. Hubble has directly imaged the nucleus for the first time. JWST detected methane in its atmosphere, a molecule never before seen in an interstellar object. And the object is still spinning faster than it was before its solar encounter, a legacy of all that outgassing as it swung close to the sun.
3i Atlas is now about 3.5 astronomical units from the sun, in the constellation Gemini. It's fading, but still reachable with a decent amateur telescope. And it has one more big act to play, a close pass by Jupiter in March, which may trigger fresh outbursts as Jupiter's tidal forces stress the nucleus.
An extraordinary object. And the fact that we have a spacecraft data downlink happening as we record today makes it entirely current. What report would JUICE found as soon as the science teams released their analysis?
Right. Deep time now. I genuinely love this next story because it takes something you thought you understood, Saturn's rings, and reframes the entire origin of the system.
New research by Mattia Chuk at the SETI Institute, about to be published in the Planetary Science Journal, proposes a dramatic two-stage catastrophe that reshaped the entire Saturnian system, roughly 400 million years ago. And I mean reshaped everything. Titan, the rings, Iapetus, Hyperion, all of it connected to one ancient collision.
Let's set the scene. Saturn has puzzled planetary scientists for a long time. Its axial tilt is an unusually steep 26.7 degrees. You don't expect gas giants to form that way. Titan is migrating away from Saturn at a surprisingly rapid rate. The moon Iapetus sits at an oddly inclined orbit, and the rings are far younger than the planet itself, only a few 100 million years old, geologically speaking. One thing after another that didn't quite add up.
Chuk and colleagues ran simulations and found a scenario that explains it all at once. The key player is a moon they're calling Proto-Hyperion. Saturn used to have this additional mid-sized satellite orbiting in the outer system. When Saturn's spin-orbit resonance with the other planets in the solar system broke down, Proto-Hyperion was destabilized. It drifted inward, and it collided with a Proto-Titan.
The merger of those two moons roughly 400 million years ago set off a chain reaction. Some of the collision debris accreted around what would become today's Titan, explaining why Titan's surface looks surprisingly young despite the moon itself being ancient. Titan absorbed new material and essentially reset its surface.
Other debris from the collision perturbed the inner moon system. Titan's resonant gravitational interaction with Proto-Dione and Proto-Rhea caused further instabilities. More collisions, more debris. Most of that material eventually reaccreted into the inner moons we see today: Nemesis, Enceladus, Tethys, Dione, Rhea. But a fraction of it stayed dispersed. That fraction became Saturn's rings.
And Hyperion, the small, oddly shaped walnut-like moon that looks like it survived a very bad day. According to the model, it actually did survive a very bad day. It formed from the debris of that Proto-Hyperion and Proto-Titan collision and was captured into resonance with Titan. The researchers note that in most of their simulations, Hyperion was lost entirely. Its survival in a relatively small number of runs suggests the real system was genuinely close to being quite different.
What I find compelling about this is how elegantly one event connects everything. The tilt of the whole planet, the age of the rings, the orbits of Iapetus and Hyperion, Titan's migration rate. One ancient merger explains it all.
Now, the researchers are careful to say this is a hypothesis, not a confirmed history. Simulations can be suggestive without being definitive. But NASA's Dragonfly mission is heading to Titan. It launches in 2028 and arrives in 2034. One of the things Dragonfly will investigate is the age and history of Titan's surface. If the surface shows evidence of that ancient resetting, that would be a powerful confirmation.
400 million years of cosmic history hiding in a walnut-shaped moon. I love this stuff.
And finally, a story that will make you rethink just how long it takes to get to Mars, or at least how long it might take one day.
Russia's state nuclear corporation, Rosatom, through its Troyes Institute near Moscow, has been developing a nuclear-powered magna plasma engine, and they're making a bold claim that this technology could get a crewed spacecraft to Mars in 30 days.
To put that in context, a conventional chemical rocket takes roughly 8 months to reach Mars. 30 days would be a transformation, not just an improvement. It would fundamentally change the feasibility of human Mars missions. Less radiation exposure for the crew, less time in microgravity, a completely different logistical calculus for resupply and emergency scenarios.
The engine works by accelerating hydrogen using electromagnetic fields rather than combustion to a velocity of 100 kilometers per second. That's roughly 22 times faster than the exhaust velocity of a conventional chemical rocket. The working body is plasma, charged particles, and it's driven by an onboard nuclear reactor that provides the sustained electrical power the accelerator needs.
Importantly, this isn't a launch engine. You'd still use conventional chemical rockets to get off Earth's surface and into orbit. The plasma system switches on once you're in space for the interplanetary cruise. Smooth, continuous acceleration followed by a long deceleration burn.
The prototype is currently running ground trials inside a 14-meter vacuum chamber designed to replicate deep space conditions. The researchers say the engine has demonstrated sufficient longevity, over 2,400 hours, for a Mars transportation operation. A flight-ready prototype is targeted for 2030.
Now, and this is important, there are real caveats here. No peer-reviewed data has been published yet. The thrust is very low, around 6 newtons. Integrating a nuclear reactor into a crewed spacecraft is an enormous engineering challenge in itself, with regulatory, thermal, and radiation shielding hurdles that remain largely unsolved publicly.
Fair points, but the broader context is genuinely interesting. NASA is investing in its own plasma propulsion programs. The Vasimir engine from Ad Astra Rocket Company in Texas targets a Mars trip of 45 to 60 days. China has plasma thruster research underway too. There's a real multi-nation push to solve the propulsion problem for deep space travel.
Chemical rockets got us to the moon. Getting to Mars regularly, safely, and at human timescales requires something different. This is where that search is heading, wherever it ultimately leads.
30 days to Mars. Even as an aspiration, that's a sentence worth sitting with.
And that's our 6 stories for Season 5, Episode 42. What a lineup! From a rocket on a launch pad in Florida, to a crescent moon swallowing Mercury, to the debris of a 400-million-year-old collision still orbiting Saturn.
And an interstellar comet sending us its last data from the edge of the solar system. While Russia dreams of getting to Mars in a month, space never has a quiet week.
If tonight's sky events caught your attention, there is still time to get outside. Mercury and the moon in the west, Jupiter and Ganymede in the southeast. You have your orders.
And keep an eye on Artemis. Tomorrow's fueling test is one of those days where the news could come fast. We'll be on it.
Thank you so much for spending part of your Wednesday with us. We'll be back tomorrow for more from the universe.
Until then, clear skies, everyone.